this lesson, we are going to introduce the concept of derivative in calculus. Our goal is introducing a new function which is denoted by f prime of x, and it is a limit of the quotient difference, and have geometric and physical meaning of this. Relate this to the concept of instantaneous rate of change. By definition, limit of f of a plus h minus f of a divided by h as h approaches 0, which is the same as a limit of f of x minus f of a over x minus a as x approaches a, is called the derivative of function f of x at x equals a, and it's denoted by f prime of a. F prime of a geometrically represents the slope of the tangent line to the graph of y equals f of x at x equals a. When we introduced instantaneous rate of change, we saw the instantaneous rate of change, which is the same as limit of f of a plus h minus f of a over h as h approaches 0, is the slope of the tangent line. Basically, if we consider in this form, I call it star, if we consider a and a plus h, 2 points, a and f of a plus h and f of a plus h, then the slope of the secant line would be f of a plus h minus f of a over h. When h is small, the secant line is getting close to the tangent line. Therefore, the limit of f of a plus h minus f of a over h as h approaches 0 geometrically is the slope of the tangent line to the graph of y equals f of x at x equals a. Therefore, f prime of a, derivative of function f at x equals a, is the same as the slope of the tangent line to the graph of the function at x equals a. Therefore, it represents the instantaneous rate of change of the function. Limit of f of x plus h minus f of x over h as h approaches 0 is a function of x. This function is called the derivative, and this definition is called the limit definition of the derivative. Some books refers to as first principle. Let's find the derivative of f of x equals 5x2 plus x plus 1 at x equals 1. F prime of 1 is limit of f of 1 plus h minus f of 1 over h as h approaches 0, which is the same as limit of 5 times 1 plus h to the power of 2 plus 1 plus h plus 1 minus 7 over h as h approaches 0. If we expand the numerator and simplify it, the limit would be the same as limit of 10h plus h2 plus h over h as h approaches 0, which is 11. Therefore, the derivative of f of x equals 5x2 plus x plus 1 at x equals 1 is 11. As you know, the instantaneous rate of change of f of x equals 5x2 plus x plus 1 at x equals 1 is also 11. Let's have another example. Let's find the derivative of f of x equals 2x plus 7. We know f prime of x is limit of f of x plus h, in this case 2x plus 2h plus 7, minus f of x minus square root of 2x plus 7 over h as h approaches 0. This limit is the derivative. So to calculate the limit, we rationalize the numerator and we simplify the function. To rationalize the numerator, we have to times both the numerator and the denominator by the conjugate of the numerator, which is square root of 2x plus 2h plus 7 plus square root of 2x plus 7. And by doing this, we have 2x plus 2h plus 7 minus 2x minus 7 on the numerator of the function. The limit would be the same as limit of 2 over square root of 2x plus 2h plus 7 plus square root of 2x plus 7 as h approaches 0, which is 1 over square root of 2x plus 7. Let's recap. By definition, limit of f of a plus h minus f of a over h as h approaches 0 is called the derivative of f of x at x equals a. Derivative of a function at the given point is the instantaneous rate of change of the function at that point, and geometrically it is the slope of the tangent line to the graph of the function at the point. Limit of f of x plus h minus f of x over h as h approaches 0 is derivative of f of x. Thank you.